Today what I want to show you is another experiment that deals with the topic of stoichiometry, but focuses down a little bit further into the idea of when reaction occurs, do you ever have anything that's all used up, or do you have things that are in excess? So I'm going to turn my computer here a little bit so you can read what I have on the board and copy this. The topic is called limiting reactant. And I'm going to use sodium bicarbonate or baking soda. I'm going to combine it with vinegar. The products will be carbon dioxide gas, sodium acetate, which will dissolve in the vinegar. We won't see it. It'll be dissolved ions. And the last product is water. So let me give you just a moment to copy that. Limiting reactant. When we do the reaction, will there be something totally used up? And will there be something that's in excess? The reaction is going to depend on the substance that's totally used up. And it's very much like the idea of the making of the sandwiches that you either heard about or probably saw in some reading that you did. The next thing I want to do is I want to balance the equation. I have one sodium over here. I have one sodium over here. That's good. They're equal. I have a carbon with 3 oxygens on it. I got a carbon with 2 oxygens on it. So we're going to have to steal an oxygen from someplace to get the things balanced. I have an acetate group, C2H3O2, and here it repeats itself, C2H3O2, and then I have a water molecule. And if I do a little chart to count up all the ions and atoms together, I will find that the coefficients that I need to balance this reaction are just ones. So let me put those in front for each compound, and you can double check that by making a little chart and count the atoms up. The quantities of the substance I'm going to use, in each case that I do this reaction, I'm going to use the vinegar, and I'm going to keep that at a constant volume. So each time I do the reaction, I'm going to use 10 milliliters of vinegar. I'm going to repeat it 3 times. So I'll put into a container 3 milliliters of vinegar acid each time. And the amounts of baking soda that I will use 1.0 grams for one trial, 1.5 grams for a second trial, and 2.0 grams for a third trial. And the idea that I have behind this experiment is to see how much CO2 we can make. So let me go back and show you this once again. 10 milliliters of the acid each time. And then my baking soda, 1, 1.5, and 2 grams. And you'll see me as I put these things together. I'm going to stop the video at this point and go over to the lab table and put all the ingredients together for you. Let me now show you a little bit of the equipment that I have on the lab tabletop here. In the background, you'll see a bottle of vinegar, and on the right, you'll see I have an electric scale, and in a small container here, I have my baking soda, a little vial of it, and then in the background, I have some film canisters. That used to be something that people would buy their film in when there were cameras that used film. I've labeled them. This is my 2 gram quantity, this is my 1.5 gram quantity, and the one I haven't filled yet is going to be my 1 gram quantity. So I have filled these with the 10 milliliters of vinegar. Let me now finish off filling this left-hand side with 10 milliliters of vinegar. There's my 10 milliliters of vinegar. I'll pour that in. I'll put the vinegar aside. When my students do this, if you were doing this, you would notice a little bit of a vinegar smell in the lab. Now the next thing is to mass out my baking soda, my sodium bicarbonate. Here's my vial, and in this first one I want to put 1 gram. So I have my massing pan on the balance. Let me tear the balance to read 0. There it is. We'll dump some in. If there's too much, we'll take some out. Just a slight amount more than 1. I'm going to take a little bit out. Just a tiny bit more. And we're reading 1.01 grams, so that's good for our experiment. We'll put that aside. And what I've done is I've put the sodium hydrogen carbonate, baking soda, on top of 3 pieces of toilet paper. Toilet paper. Call it tissue if you need to. So what my next plan is to take these outside, down in the plaza, and wrap up the toilet paper, put it into the canister, let the reaction take place. It'll build up some carbon dioxide and hopefully push the lid off. That's what we're aiming to do. Now, when I say push the lid off, it sometimes does that with a lot of energy. So to kind of capture that and take a better look at it, what I've also done is I've put together a lab stand. I've got a big beaker here, and I have bought some PVC pipe, plastic pipe. It is hollow. Let's see if we can get you to see that. Yeah, good. And what I'll do is I'll put this into a clamp, put it all the way to the bottom, clamp it up, and then when I get outside, what I will do is I'll take a little bit of tissue paper and drop it in, close the lid on the little canister real quick, and flip it over upside down and put it into the tube. And if it reacts, it may launch the little canister for us, and hopefully we'll see something like that. And then what we want to do is kind of compare and see how the amounts of sodium bicarbonate affected how the launching process went. A lot of times when I do this, we get a dud, doesn't work at all. And the little tube here will guide the canister vertically, and I'll try to estimate how high the canister might fly. So I'm going to turn off the video here and get set up outside in the plaza. Well, we're all set to go with our reaction. What I've done is I've put the baking soda on the paper, but I've covered each paper with a beaker because it's been windy out here, and I knew that if I tried to do this without a cover on the sodium bicarbonate, it would all be blown away. And that has happened in the past. There are occasionally times when I've done this experiment where the students get everything measured, a gust of wind comes on and blows it off. So let me take my first sample here and we'll wrap it up in the paper. Put that beaker aside. Here's my 10 milliliters. And what I'll do is I'll drop it in real quick and then drop it upside down into the tube. And then we'll see if we get a reaction. Shake it a little bit, drop it in. Oh yeah. It landed about 2 inches away from my computer here. That's our first reaction. That was the one done with 10 milliliters of vinegar and 1 gram of sodium bicarbonate. So let me put that one aside. I still have a lid in here, so I'm going to stop the computer for just a second so I can retrieve that lid and get ready for a second reaction. This is the end product of my first reaction. I got the lid in here, I got the piece of toilet paper, and we have some dissolved baking soda. Now, we'll dump this out and we'll get ready to do our second trial. This is now trial number 2. This has 1.5 grams of baking soda, still the 10 milliliters of vinegar. Wrap it up, put the lid on, and drop it in. I didn't shake this one up. Pretty good. Fortunately, they're landing slightly downwind of me. That's good. I'll lift up the tube, dump out the contents again, and then we'll try the third one. I'm going to try to estimate by standing away from this roughly how high the canister goes. That was 1.5 grams. This will be our final one, the 2 gram sample, and I'll probably even try to aim the computer up a little bit so maybe we get a little bit of the trajectory of the canister. So our first one was just 1 gram. This one's 1.5. This last one here will be 2 grams of baking soda. Let's put that one together. And on this one, I'm going to purposely aim the computer up in the air so that if we get a chance to see the height of the launch, that'll give us an idea of how powerful this one is, if it's powerful at all. So we'll just aim this upwards and see if it reaches to a certain height up here. I'm dumping in the taper. And we're getting a bubbling reaction already. So we'll drop it in. This one might be leaking on me. It was leaking, but still reacted pretty vigorously. And you guys will have to probably do a little estimation as to how high that canister went. I'm standing in the plaza here, so our first floor windows are right behind me here, and there's our second floor windows. Give us an estimate of how high that went. Now let me turn this off. And the final ideas I want to just show you very quickly are some of the ways that we can write this reaction. First of all, once again, here's one of the beakers. In the bottom I have that paper plus the lid, and there's some liquid in here and has a little bit of a vinegar smell to it. When I show all the chemicals put together, over on the left there I have sodium hydrogen carbonate. I started with that. It's a solid, so I have in parentheses down here a little S surrounded by parentheses. And then the next ingredient is my vinegar. I have it up here, but then in reality it's actually a solution of hydrogen ions plus acetate ions, and that's the way I show it here. In each case, the hydrogen ion is aqueous, AQ, and the acetate ion is aqueous. They're both dissolved in water because vinegar is actually a solution of an acid in water. The products are carbon dioxide, and that's shown as a gas, little g in parentheses. My other product is water, L in parentheses, and my other end products are sodium and acetate ions that are floating around in that liquid, and both of those are aqueous. And if I were to pour this stuff down the sink, this would go down the sink, but it's very, very safe. In fact, this whole reaction is one that you can do at home. It's a very safe reaction because you're working with baking soda and vinegar. The only thing you would have to be aware of is the potential for some flying object to come up and hit you in the eye. But the chemicals that I've used, you probably have them at home. So that wraps up our illustration for the limiting reactant.